Okay, team challenge number 5 is the third in a series. It started with team challenge number 3 when you made a buffer, and team challenge number 4 where you did one buffering capacity type question. This is the other buffering capacity type question. So, in this one, you took 70 mils of your buffer and you put it in a beaker, okay? And you're going to add 5 mils of 70 millimolar NaOH to it. Okay, that's the question. What's the pH at the end? Okay. So we can go back to what we had from the previous question to start. From the previous questions, the one where we figured out the buffer, we knew that the concentration of HA is 0.00875 moles per liter. Okay, and the concentration of A minus is 0.06125 moles per liter. Great, so we know what our concentrations were that we figured out the last time. Now we have to figure out how many moles we have in that beaker of each of these two species that are making up the buffer. So we have in there 70 mils, 0.07 liters, okay? So now we can figure out how many moles of each we have. That is 0.0006125 moles of HA. Yep. And we have 0.00429 moles of A minus. If you look at this question, you'll see we had a much higher concentration of A minus. Therefore, more tenfold more A minus than HA in terms of moles. Okay, so that's where we're starting the question. Then we added this much base. So that's 0.005 liters times 0.07 moles per liter, which is 0.00035 moles of OH minus. When you add OH minus to a buffer, it rips off the H off of HA and makes that into A minus and makes water with the H plus there. So we have to subtract the 0.00035 from our HA moles, and we have to add them over here to the A minus moles. So what we've done is we've converted HA into A minus when we add base to this. Okay, so that's going to give us some new numbers of moles. So we'll have our new numbers of moles for HA coming from here, and that is 2.625 times 10 to the minus 4. Or 0.0002625, and the new moles of A minus would be bigger than they were before, 4.638 times 10 to the minus 3, or 0.004638 moles. Now what we have to do to figure out the pH is put it back in Henderson-Hasselbalch. pH is pKa plus the log of A minus over HA. We'll just use the number of moles since they're in the same volume. The pKa from the previous question was 6.15 plus the log of A minus, 4.638 times 10 to the minus 3 over 2.625 times 10 to the minus 4. And that gives us a pH of 7.40. Okay, so that is the pH once I've added that to 70 mils of buffer. It's always a really good idea to say, well, what would happen, what would the pH be if I added that same amount of strong base to water instead? What would the pH be? So let's look at that instead. If we had that same number of moles of base, which is 0.00035 moles of OH, in now 70 plus 5. So it's 70 mils of water plus 5 mils, okay? So in 0.075 liters. So you've got to add together the 70 mils of water and the 5 mils of base. That gives us, we figure that out what the concentration is, take the negative log, and that gives us POH, right, which is 2.33, which would give us a pH, which is 14 minus the POH, of 11.67. So the take-home message there is that when you added the 5 mils of strong base to a buffer, it took the pH from 7 to 7.4. And when you added 5 mils of the strong base to water, it took the pH all the way up to 11.67. Water does not buffer. The weak acid solution does buffer well. So that's how you do that.